Hello, welcome back. In this video, we'll discuss certain useful terms and a brief introduction to magnetic materials. Magnetic susceptibility. The magnetic susceptibility is defined as the ratio of intensity of magnetization produced in the sample to the magnetic field intensity which produces the magnetization. Since it is a ratio, it has no units. It is represented with a chi and it is defined as ratio of intensity of magnetization produced in the sample to the magnetic field intensity which produces magnetization. It is represented with a chi, and chi is equal to m upon h, where m is the magnetization and h is the magnetic field intensity. Now we shall see what is magnetization. Process of converting a non-magnetic material into a magnetic material is called as magnetization. So essentially it is a process. The process of converting a non-magnetic material to a magnetic material. It is a name of the process. Intensity of magnetization. It is magnetic moment per unit volume. Relative permeability. The ratio of flux density produced in a material to the flux density produced in vacuum by the same magnetizing force is called as relative permeability. So we are comparing the flux density produced in a medium to the flux density that is produced in vacuum. Ratio of flux density produced in a material to the flux density produced in vacuum by the same magnetic force. Magnetic flux phi. The magnetic flux is represented with a phi. It is defined as the total number of magnetic lines of force in a magnetic field. The units are Weber. Magnetic flux density. It is defined as the magnetic flux per unit area at right angles to the direction of the flux. The units are obviously Weber per meter square. Magnetic flux per unit area at right angles to the direction of flux. Its units are Weber per meter square. Magnetic flux intensity. It is represented with a capital H. It is defined as the magnetomotive force per unit length of the magnetic circuit. It is also called the magnetic field strength or magnetizing force. So it is defined as magnetomotive force per unit length of the magnetic circuit. It's also called as magnetic field strength or magnetizing force. The units are ampere turns per meter. Permeability. It is represented with a mu. The ability of a material to conduct magnetic flux through it is called permeability. Is called permeability, and the units are, that is, henries per meter. Magnetism is mainly due to the dipoles. Magnetism in a material is due to magnetic dipoles. Magnetic materials further are classified using the presence of magnetic dipoles in a material and also their orientation in the material. We'll start with the diamagnetism. The diamagnetic materials, they lack the permanent magnetic dipoles, hence they are called as diamagnetic. So the materials which lack permanent magnetic dipoles are called diamagnetic. Next we'll look at the paramagnetic materials. If the permanent dipoles do not interact among themselves, then the materials are called as paramagnetic materials, which means permanent dipoles are present in the paramagnetic materials, but they do not interact among themselves. As a result, you have a special category of materials known as paramagnetic materials. If the permanent magnetic dipoles do not interact among themselves, then the material is called paramagnetic. Ferromagnetic. If the interaction among permanent magnetic dipoles is strong, such that all the dipoles line up in parallel, then the material is called as ferromagnetic materials. Means in the ferromagnetic materials, permanent magnetic dipoles are present, and those permanent magnetic dipoles are aligned in one particular direction. If the interaction among permanent dipoles, magnetic dipoles is strong, such that all the dipoles are line up in parallel, then the material is a ferromagnetic, antiferromagnetic. In the antiferromagnetic materials also, the dipoles are present, but if the permanent dipoles line up in anti-parallel directions, then the material is called as antiferromagnetic material. If the permanent dipoles line up in anti-parallel direction, the material is antiferromagnetic. Lastly, the ferrimagnetism. In the case of ferrimagnetic materials, the antiparallel magnetic dipoles, they are not equal in number and they are not equal in magnitude. So the dipoles are antiparallel with unequal magnitude. In this video, we have tried to understand certain useful terms and introduction to magnetic materials. Magnetic susceptibility, which is represented using a µ, it is defined as the ratio of intensity of magnetization produced in the sample to the magnetic field intensity which produces the magnetization. So µ is equal to m upon h, where m is magnetization and h is magnetic field intensity. Magnetization is the process of converting a non-magnetic material to a magnetic material. We have also seen the intensity of magnetization, the relative permeability, magnetic flux density, magnetic flux intensity, and permeability. Using the presence of the magnetic dipoles, magnetic materials can be classified into diamagnetic materials where no permanent magnetic dipoles are present, paramagnetic materials where permanent magnetic dipoles are present but they do not interact among themselves, ferromagnetic materials where the permanent magnetic dipoles, they interact among themselves strongly and they line up in one particular direction. We have also seen antiferromagnetic materials and ferrimagnetic materials. Thank you.